afternoon, everyone, and welcome to the latest episode of our MSME Masterclass. Today, we are diving into a topic that's often underestimated but absolutely critical for manufacturing success, which is material selection and smart metal choices. And to help us decode this, we are joined by someone who lives and breathes specialty metals and industry-grade materials. Please join me in welcoming Mr. Kairav Domadia, Director at Domadia Group, a family-run enterprise with over 3 decades of expertise in supplying high-performance metals and alloys across India's industrial ecosystem. Kairav brings over 25 years of personal expertise and experience in helping MSMEs and manufacturers choose the right materials for the right applications, from copper and nickel alloys to super alloys like Inconel and Monel, industrial powders, non-sparking tools, and more. What makes him particularly relevant for our audience today is his practical understanding of grade selection, material compatibility, counterfeit avoidance, and how the right metal can dramatically impact performance, durability, and safety in sectors like fabrication, furnaces, electrical systems, and heavy engineering. So if you've ever struggled to decide which metal is best for your product, your process, or your environment, this session is packed with practical insights. Let's dive in. Welcome, Kairav. Welcome to our MSME Masterclass.
Hello, Amrita. Thank you so much. It was a lovely introduction.
Thank you, Kairav. Kairav, we'll quickly begin with our first question, which is, what does smart metal choice really mean in manufacturing context?
Smart metal choice, huh? Okay. Smart metal choice is about reducing the problems later rather than trying to cut down costs now. It is about keeping the customer happy. Of course, that is the number one reason you have to when you make a product. But in metals, the cost of rework, of failure, rusting, and customer complaints are very expensive because metal is always a heavy product. So bringing it back, the logistic cost will also be high. Plus, you lose your goodwill in the customer's mind. So choose the right metal before you make the product. That is my suggestion. So smart, like for example, steel works mostly everywhere, right? But in steel, there are various grades. If you see in cutlery, people mostly use SS302. But there are manufacturers like Kishko, if you know of, they are amazing manufacturers who use SS316 because their customers are somebody who are going to use this cutlery for years to come. And this is where you choose the right metal according to the right client. This is my suggestion, of course.
Okay, Kairav, for a small or a mid-sized unit, how do you even begin choosing the right metal for a product or an application?
Today's world, we are blessed with AI, first of all, right? So you don't really need to ask 5,000 people anymore, right? First, you choose your product. What is the product that you're going to make? You decide the life cycle of the product. You have to ask this to your customer, that how long are you going to keep this product for? What is the life cycle going to be like? Is it going to be only there on the shelf for 1 month or 6 months or years to come? According to that, you choose the grade, number one. Number two, you also see the environment. When I say environment, means are you putting the product outdoor or indoor? Is the product going to be exposed to different kind of chemicals or water or moisture in the air? All those environmental factors take place, which is very important. Number three, of course, the cost comes in, so you need to choose the right metal according to the cost that is being given to you. You need to play by the book, of course. And what is the process the metal needs to make it? So the cost of process is very important. So every metal, the cost of process is very different. So that you need to know before you choose it. First is always ask the customer what they need, what are their expectations. Don't just copy paste, I would put it that way, from somebody else saying that, yeah, this guy is making this out of this. No, don't do that. You innovate a little bit. You ask the customer what is the application, what is the process that you require, what is the lifeline that you require, and according to that, you decide. For example, aluminum is superb to use outside, right? But steel will rust. So when you're making a product that is going to be placed outside in the open, it's better to use aluminum. It is cheaper than steel, lighter than steel, and more cost effective. and still it does the better job. Okay, so this is my takeaway.
Got it. Understood. Kairav, some of our attendees have in the previous past sessions also asked us what are some early stage mistakes that they can make when sourcing metals for manufacturing.
One is always the wrong size. You need to be sure about the size that you're buying. Number two, you need to know the grade that you're buying. Metals have more than 1,000 grades, right? You need to be sure about the grade that you're buying. You need to always get a manufacturer's test report. Right? Now what you can do is you can pick up the test report and get it tested with a third-party lab. In India, there are hundreds of labs that do a third-party testing, which will assure you that the material supplied by the manufacturer is exactly matching to what you need. Right? So I would put it that way. The problem does not really start at production. The problem starts at purchasing. Now, the purchase guys need to do all this job before the material even reaches the production stage. This is to avoid any failures later. So do this homework before the material reaches your works or your warehouse or your factory. And this will ensure to reduce the failures. This is a program, I would put it that way.
Got it. Yeah. Kairav, according to you, do you think there is a framework or a checklist that fabricators can use to compare different types of steel or alloy options?
Sorry. There isn't really a written framework, I would put it that way. But you need to, again, as I said, you need to check your environment, you need to check the grade, you need to do the tests, you need to do the NABL tests, you need to check the strength of the material which you're going to be using. Is it compatible to the product where you're going to be applying the same? Now, if the product is going to be dropped somewhere, the strength needs to be much more. Whereas if the product is going to be kept high up on a tree, the strength may not be required to be very high because it's going to be safe up there. So strength, environment where it's going to be used, like it's going to be used open or close, like we discussed before. While you're manufacturing the same, what are the problems that you're going to occur? While manufacturing the same, is it weldable? Are you going to be able to weld it with the product that you're already using? And most important factor is the availability. Now, every country has a strength of metals, like India is super with steel, right? But India does not have all the rare earths. So when you buy super materials or specialized materials, all materials are not made in India because India does not have the rare earths or the necessary mines to make it. So every country, mostly every country, I'll put it, is interdependent with each other for many metals and alloys. So you need to know the availability of the metal. So when you get a repeat order, are you going to be able to supply to the customer? Are you going to be able to keep the customer happy? Are you going to be able to do repeat business? Otherwise, it makes no sense to do one-time business, right? Everybody is here for repeat business, right? So this is something that is very important to make sure is the availability. So, and the better way to do it is have 2 or 3 suppliers, make sure they are good suppliers and keep them in your database. So whenever there is a problem, you know you can find another supplier for us. This is one of the things I would put.
Kairav, you also hear, rather often hear terms like steel, magnesium, titanium. Could you break that down for us in simple terms?
Okay. Most people know metals. When I say metals, most people will know copper, brass, aluminum, steel. Now, these other materials, titanium, magnesium, these are all very different materials. Like, these are not something that you hear day to day, right? Now, for example, titanium is a fantastic material, right? It is half the weight of steel, but of course, it is much more expensive, right? Now, magnesium is 1/4 the weight of steel, right? And it is one of the lightest structural alloys in the world. Let me repeat this: lightest structural alloy in the world. Now, I would keep a simple rule. One is, if steel works for you, do not change it. Or if I would put it, any metal is working for you, everything is fine, of course, do not change it. You will But of course, you have to make the right decision while starting the process. Right now, everybody only talks about the price, right? That hey, the price of titanium is so high, the price of magnesium is so high, the price of beryllium copper is so high. Let's not do that. Let's compare the value of the product also. Let me explain you in a very simple jargon, right? Now, for example, if I take one sheet of 1 mm of steel, okay, say 1 meter by 1 meter for an example, okay, this is a rough estimate. Now, that sheet will be around 8 kgs. Now, it will cost you around 2,500 bucks. I'm talking in Indian rupees as of today, okay, approximately. Whereas, same thing in titanium will cost you around 10,000 bucks. Same thing in magnesium. Let me tell you this: titanium weighs half, almost 4.5 kgs, whereas the steel would weigh 8 kgs. Right? Now, if you are using magnesium, it will only weigh 2 kgs of the same size of sheet, and it will cost you 7,000 bucks. Right? Now, these are different materials used for different things, but you have to understand you are only paying a little bit more, yes. But what is the problem? For example, magnesium being the lightest material, it is very easy to use in drones, right? Like carbon fiber and magnesium are highly used in drones. Whereas titanium is highly used in ships because it has a very good anti-corrosion properties. There is a saying they say, if you take titanium and put it in the sea for 100 years, it will not rust. That is the reason that titanium is used in ships a lot. Like, okay, I'll give you one more example that if you have to get a ship back and change the base, it is going to be horribly difficult, right? That is the reason they use a lot of titanium there, because it keeps the ships for like ever. This is, yeah. So I'll say if steel works, do not upgrade. If you choose aluminum over steel because of its lighter weight and its outdoor use and it's non-corrosive, yes, keep that rule. This is superb. But there are places where you will need titanium, like in your implants, in your bones. Titanium is used, and that is a better material because you're going to be using it for all your life inside your body. You should not put steel. You should, because steel will rust at some point of time. And magnesium is a new material and very slowly explored by the MSMEs of India.
Great, got it.
Several such materials which have several applications and several uses, I will put it. So you need to know what you need to use, and you need to know the end use.
Understood.
Yeah.
Can you tell our attendees how big a role does end use environment play in choosing the right metals, especially like temperatures or exposure to chemicals and stuff like that?
Very important. Very, very important. Yeah. All parts don't fail because they are weak or they are not made well. They fail because either the condition where it is going to be used is not known to the manufacturer. He's not being told that he's been told, hey, make this part for me from SS or from MS or something. He's not been told, or he's also not asked to his client that what is the application. Because of which, what happens is the material fails either by rusting or cracking due to high heat. Like for example, if you're going to be supplying something in Bombay, I'm in Bombay, and Bombay is near the sea, and the rusting is very high. Now the same thing you can easily supply in Rajasthan, and the product will last much longer. It might not rust very easily. But if you're going to be supplying something to the Middle East, where the temperatures go so high, you better know the product well. This is the reason I would say you need to know the end application. Always insist on asking the client what is the end application before you choose what material you need to use. Right? Again, I'll come back to the marine industry. Like marine industry uses titanium a lot because titanium does not rust in the sea. Right? Now, India recycles a lot of titanium because we are the Alang, if you know, in Gujarat, there is a place called Alang. It is called the graveyard of ships. Okay, it's popularly known as the graveyard. If you go there, every day tons of titanium is scrapped there. And India recycles that and reuses it. And it is one of the best materials. You can go to Alang, it's near Bhavnagar, Gujarat. And a lot of other materials also come out of that, MS and steel and all that. But titanium is one of the major materials that gets sold. So I think you need to know end condition. The first thing you should always ask a client, where are you going to install? So you can then decide whether you want to do any kind of coating on it. And that also can really help the material's life.
Got it. How can MSMEs, Kairav, according to you, balance cost and performance when it comes to metal selection?
Okay, metal selection, don't only look at the price, don't only look at the rejection rate, look at the machining time that it's going to take. Yeah. Look at the coating cost. You might sometimes, as I said, you need to coat the material, or you need to do some kind of layering on it. Is that more expensive than buying a higher grade, or buying a cheaper grade and doing a coating will make the material last longer? This is an R&D that both the customer and you need to do. Sometimes you don't have the ability to do that R&D because only the customer has the ability. So give this option to the customer, saying that, hey, I'm going to give you two products. One is a higher grade and one is a lower grade with a better coating. And this can be a game changer for them. Right? You can also know what is the maintenance cost, warranty issues. Like if the product is so huge that you need to transport it back, and that cost of transportation is sometimes even more than the material, right? Then it makes no sense to go for a cheaper material. Then it is always better to go for a higher material. Like I'll give you an example, a very small example, right? You see switches at your home, right? In these switches, have you ever switched on and seen a spark?
Yes. Multiple times.
Okay. Now, if you are in a coal mine, are you going to be okay with that switch?
No.
Or a gas chamber, you're not going to be okay with that switch, right? When we are taught safety, we've been always taught, if there is a gas leak, do not use the switch. Correct. The reason is every switch has a brass part inside it, which licks a little bit when you switch it on or switch it off, any of it. Now, if you replace that brass part with beryllium copper, I repeat, if you replace a brass or a PB part with beryllium copper, that spark will go away forever. You will never see that spark. Number one. Number two, the switch will last at least 100 times more than the regular brass or a PB switch. I don't know about the plastic part, but the metal part will last at least that much. Now, what is the difference in the cost while you manufacturing that part? Can you guess?
Probably double the price of the normal switches.
No. So if you buy a switch of say 500 bucks on an average, or 300 bucks, right? This material replacement will only cost 5 bucks.
Oh my god, okay.
But yet, either the switch manufacturers are not aware about this, or they're like, chalta hai, how in India it is. It is working, I don't want to change it, my customers are happy.
Correct.
But customers are not aware. If you add this one bit, that this is a safety switch, this is a switch that is not going to let a fire happen if there is a gas leak. Right? We always see this ad since childhood, Havel's wire, the wire that does not catch fire. Yeah, but it's a very cute ad. But the switch can catch the fire. What about that? We need to keep that also in mind, right? It's the wire. It's not more factors than just the wire. You see? So I'll put it that way, that yes, sometimes a little bit of cost can improve the product drastically. And a lot of times manufacturers try to save this cost. And as a supplier, I am not happy about that. Yeah, but well, I don't have a choice. If somebody is asking for X, I have to give him X. I cannot push him to buy Y.
Right.
Yeah, but I really want to educate them, saying that, hey, this is the reason I am saying to buy this. Yeah, the cost is $5 is really nothing. You won't even know when you go to buy a switch whether it is 255 rupees or 245 rupees. It won't matter.
Right, you're absolutely right.
But if you know this thing, if I'm going to put both the products in front of you, saying that hey, this is $240 and this is $250, 5 rupees difference, but this is never going to catch fire if when there is a gas leak. You know you are not even ever going to have a gas leak. You're very sure about that. You've always been very certain. Your mom makes sure you switch off the gas, but you will still spend that $5 more.
Safety first, always.
Safety first. So this is what something that I feel that a lot of people need to work on. I really safety.
Understood.
Yes.
Kairav, in your experience, which metal selection mistakes lead to the highest rate of product failure or rejection?
Condition, end-use condition. Yeah, you are not aware about the end-use condition. So what you do is you buy the wrong grade or the wrong product, absolutely the wrong product. Yeah. Poor workability means when you're trying to manufacture a product, when you're trying to machine it, because of the wrong grade, you're not able to machine it well. Because of which you get into trouble while supplying to the client. You are ignoring the factors which come into play later, like corrosion and heat or the environment and all that. So again, you are not. If you are not aware, you don't care because you're just doing what the customer has told you, right? And this is where, and you're not even aware about the cycles it is going to be used for. For example, a switch in our home, we switch on multiple times in a day. Yeah, but switch in our office, you will only switch on in the morning and switch it off in the night while leaving. So the house switch needs to have a better cycle or a better quality than an office switch sometimes. Yeah, because the reason we are going to be using that multiple times. So the cycle is also very important. So I would say the most failures are never sudden. It is not something that it's just going to, you buy it and tomorrow it fails, right? It is always a usage. It breaks down slowly. Yeah, and you feel, oops, I think this product they gave me faulty. Sometimes we feel that way, but it's not that. The life cycle of that product was only that much. So this is where a lot of good electrical contractors come in. When you're getting an electrical contractor for making your building or making your office, like you're trying to save cost by asking to contractors whether should I put an isolator or a circuit breaker, but you don't know the difference. So if you now find out what is the exact difference, and you know though the cost is much more, you will still go for a better product to make sure your safety comes first, right? And the life of the product comes first. A breakdown is not acceptable in many cases. In many factories, cannot break down. Like a furnace in a JSW must have not shut down since probably 50 years. They never shut down a furnace. So the switch of the furnace is never something that they will compromise on, or the cables that go, they cannot compromise on it, right? Because they know the life cycle is very, very, very high. So I think, in my experience, I think it is a lot of factors that come into play, not just one. So I think you need to be more aware and client focused and asking what is the environment, where are you going to use, and things like that.
Do you think MSMEs are investing enough in understanding metal fatigue or corrosion resistance or weldability during the design stage?
No, honestly no. Because the industry has moved in a pattern, I would put it that way. We have started to believe in the Chinese copy-paste system. Yeah? And we don't do any of our R&D. But let me tell you something, now China does a huge amount of R&D. Yeah? Our companies also can do a lot of R&D, number one. And this R&D is not expensive. Let me tell you that also. It's not always an expensive R&D. Sometimes even by talking to some people, you will know a lot of things, that why I need to buy this or why I should not buy this. Number one. Sorry, just a minute. So yes, you need to spend money on R&D. You need to do your trials, experiments. It can be at a low cost. Yeah. Do not hesitate to ask for help. I would put it that way. We have a lot of people who are from IITs and IISCs and these big institutions who are very knowledgeable. Since we supply materials to all these ISRO and HAM and BEL, NFTDC, nuclear fuel complex, we supply a lot of materials to all these guys. They are very lovely people, I would put it that way. They are very helpful. If you call them and ask them, hey, I need help with this. I'm not able to judge what material I should buy or I should use. I am failing here. Even if they don't know the answer, they will find out from their colleagues. And they have a huge network, let me tell you that. And they will reply to you. And they will help you with it. And they are true helpers, they're true givers. And these are the people you directly call them and ask them, can you help me with this? And I'm telling you, most people in India I've seen do not hesitate to say, yes, I will help. Yes, of course, you need to focus on the part fate and how long it will survive and everything, the material failures and everything, yes. But most important thing is to ask for help. And a lot of MSMEs, either due to shyness or not being aware, today there are forums online. Yeah, you can go to Reddit and there are forums online where you can ask these questions. And there are scientists who will reply to you, who have done research papers on this, and they will reply to you and they'll tell you, bro, do this, and this will help you reduce the cost as well as give you a better product. Because do not forget, what are you doing? You're doing Make in India. You're not only spoiling your goodwill, you're spoiling the country's goodwill by supplying a wrong product. Whether you're exporting it or whether you're supplying abroad, the value still remains the same. Make in India. And should be very good. It should not come with saying, okay, chalega, nahi chalega. Nahi chalega. So yes, do a lot of R&D and do not hesitate to ask for help.
Kairav, do you think choosing the right metal upfront can actually reduce downstream costs like machining, coating, or maintenance costs?
See, machining cost is directly related to the metal, right? So machining cost is decided in the beginning. It's not decided something like by choosing the right metal, your machining cost will improve. It's not going to improve. It is going to remain the same. The tools that you need to machine a steel or tools that you need to machine a titanium are way different. Right? Now the thing is, you have to choose the right metal no matter what. Before what you will save is the man hours later. Because if the product fails, it comes back, so much of transportation, so much of loss of the environment because of burning of fuel, so much of energy is wasted, so much of man hours is wasted. Again, you go through the whole process of buying the metal, machining it, supplying it, getting it tested, and all those hours. The whole cycle is repeated. Don't repeat the same cycle. Yeah. Let's do new mistakes, but let's do good mistakes. Yeah. So it will reduce your tooling cost if you do right through the method. It will bad metal will give you a lot of hidden costs and hidden expenses later. You will save today, but later you will be in a trouble. So today, choose the metal wisely. Go with your clients' suggestions and go with your suggestions with all your suppliers. Your suppliers also have a lot of knowledge. It's always good to always ask your suppliers if this material can be used in this. Many a times they will tell you the truth. They will tell you, no, you cannot use this. Like we supply various grades of beryllium copper. Okay. Now there is one grade of beryllium copper that cannot be welded, right? So whenever somebody asks us, I want to use this material, right? We say you can use this material. We always ask for the application first. He will say, my application is welding. I need to weld this. So I will say, you cannot use this material for welding. It is not weldable. And they say, oh, but our procurement team has told us, the machining team has told us to get this material. I said, I'm happy to supply. I have the material with me, but it is not weldable. You need to go back to your team and tell them you have chosen the wrong grade. And tell them this is the right grade and this is the one you should be using. So sometimes it is a loss for me when I do this. Let me tell you, I'm supplying a cheaper grade to them than an expensive grade. But I will never want to supply a wrong grade to them. Right? Otherwise, they will lose faith saying that one, this guy is a cheat, he does not give us the right grade or the right material. Or he will think my material failed. But he is not aware that he's chosen the wrong material. So we avoid all that, and to avoid all that, we go through, we communicate with the clients a lot before giving him the material. It could be a headache for the client sometimes. He says, hey, just give me the material. And I say, okay, I can give it to you, but I'm going to put a disclaimer saying that you're choosing the wrong material. Right? But it is better for the client. In a long run, I do not want one client to be unhappy ever. Second, why waste his time on machining and everything? The cost of material is nothing compared to the machining cost and the problem that his customer is going to be facing. Right?
Correct.
I want to keep a long-term goal in mind and not a short-term.
I think this educating the customers right at the start would help.
Yes, asking and educating.
Right.
Yeah.
Kairav, how should manufacturers account for availability or supply chain disruptions when locking in material specs?
Okay, that's a very good question. Yeah. One is never depend on one grade. Yeah. Always find alternate grades to a material. For example, the Indian Army or the Indian Defense or the Indian Aerospace and all that, or the whole Indian defense industry has all the grades listed to them by the Russian standards. Okay? Now, India has lovely relations with Russia, so getting a material is not such a big problem. Number one. The problem comes in is when there is a volume problem. For example, India only, so the client only needs 100 kgs. And the Russia guy says, hey, I can only give you one container, which is 10 tons. Now, there is a gap, right? Now, we cannot, nobody can buy 10 tons to supply 100. So, now the client is stuck saying that, hey, the government is stuck saying that, hey, we are not getting the material. There is an alternate grade according to one is the GOST standard, GOST standard of the Russia. Second is the American standard, ASTM. And then there is a European standard, UNS, right? So, according to all the standards, there are different grades. You need to unify these, saying that I can alternatively use a UNS C17200 compared to a ASTM or compared to a GOST. So, if you have a parity of all the standards, saying that I can use this, then your life is much easier. So do that in the start, right? Or keep amending, keep back working on your data that you have, saying which other standard can be used for this. And you will know there is an alternative. So that is one thing that you definitely need to do. Second, approve those grades. Do the trials and approve those grades whether they are working on, right? Then you need to know where are the main suppliers for these grades. Where in the world are the main suppliers for this? Right? Now, example, if there is a supplier in US, in Europe, in Russia, you are pretty much safe because you are not going to go to war with every country in the world. You are going to get from somewhere or the other. But you are going to buy a material that is only 100% Russian. You will get into trouble someday because They may have a lot of orders and they are not able to supply you for a long time. And then you get stuck. But if you had an alternate idea ready, you'll be like, okay, chalega, I can run my show with this. And I'm not going to be stuck. My customer is not going to suffer. I'm not going to be getting stuck. My business is not going to stop. My mill will keep rolling. So these are the most important things. So yes, also with old problems, today we are facing a lot of problems with all the materials in the world and the war that's going on, and it's cold and it's hot, and procuring rare earths from different places in the world is a problem. The prices of metals have shot up like crazy, and this is when everybody starts looking for different materials. Please do not wait for such a situation. Have backup ready. Have thought processes ready. Have documentation ready saying this material will work if this doesn't work. Have alternate supplies ready. Have this database at your end ready so that when there is trouble, you're like, I'm okay. Let there be trouble. I'm still going to be running my show. I'm still going to be running my business.
Kairav, with so many metal options out there, when should an MSME consider switching from steel to aluminium or vice versa?
So the steel and aluminium are very different materials. Steel is different, aluminium is different, titanium is different, brass is different. All materials are very different. You have to always first ask the customer. Second, you have to always know where it is going to be used again, right? So you need to educate your customers, saying that, hey, these are the problems that you will face with this material. These are the problems that you will be much safer if you use this instead of this. Yeah. So you need to know switch. I would say switch only if you need to do the following things. One, you need to reduce the overall weight. So if you need to reduce the overall weight, you can move from steel to titanium or from steel to aluminium, because you will reduce the weight drastically, right? Second, corrosion. Where there is a rusting, is there a customer facing a problem with rusting, or what problems is he facing? Third is design. Now we are in a world of mobile phones which have become so thin, right? From our giant phones that we used to use. I don't know, you must have probably never seen those. We used to use those big landline phones once upon a time. So now it has become so thin. So which means the same communication is being done to a smaller device instead of such a big device, right? Which means there is so much R&D happening. There is so much growth happening. So you need to understand new materials, whether by making it more, by using this material, I can reduce the size of the component. Make it more economical and more friendly to ship, to use, to produce and everything. And is it still going to give me the same or better results? Not only same, better results, right? So I would say a lot of things are at play, but if you keep doing R&D a little bit, you will find a lot of answers to it. Yeah.
Kairav, can you also share an example with our attendees where changing the base metal transformed the performance or cost efficiency of a product?
Cost efficiency of the product. Okay, now I did. What we did is, at Tata Motors Pune, they have a wire. So we are also into high temperature insulations for cables. They have cables that can withstand up to 1000 degrees. These are cables that are used in furnaces and heaters and things like that. Most of these cables that you see, the household cables, are usually the working temperatures between 60 to 100 degrees. And the cable that we manufacture is for 1000 degree applications, 500 to 1000 degree applications. Now, they had a Cat 6 cable that we supplied to them. Now, they were changing this cable every 18 days, if I'm not mistaken, because of the high heat there. So, we just happened to have a conversation with them, saying that, hey, do you supply this cable? Can you do something about it? And we are really tired of changing every 18 days and 17 days. And it's become a headache to us. It's not about the cost, but it is a headache. to do this. And if you forget, the results on the screen are not good. So I said, hey, what I can do is you send me the cable first. Let me solve the problem. Second, send me the picture of the problem, like where you're using this cable. I want some pictures so I can understand what is the environment, right? So they're like, okay, so we did all that. We took the cable, we insulated the cable from a third party because we don't have that facility at our end. Using some insulation material that we have and the knowledge that we have. And it has been 1 year that they haven't had to change that cable. So yes, it had a cost, it had a process, but it also had the mindset of that person in Tata saying that, let me check if there can be a solution to this. And that really has solved this issue. He's called up few people. He must have not only called me up, I'm sure he's called up 20 other people and said, what can be done about this? Can you supply me a better cable? And I knew there is not a better cable for this, but there is a better insulation to stop this cable. And this is what we did and solved the issue. A small cost. The cost was negligible compared to the changes that they were doing and apart from man hours. I'm not even calculating the man hours. So that negligible change has got a huge impact in them.
For cast components, what special considerations go into selecting the right grade of material?
Cast components are, we are not specialized in cast components, I would put it that way, but casting needs metals, of course, yes. So you will always get the right purity of the ingots that you're buying. So again, do a third-party test when you're buying. Because most of the ingots of copper, brass, aluminum are recycled. So you need to get a proper test report checking the lead content, number one. When you do that, when you're okay, everything is there in the test report, you will feel that the flow is better of the metal. There is a less of shrinkage or wastage or vaporization of it. Right? So that way you will save on that and you will save the environment also because it will pollute less. Yeah? You can machine the end product better, right? Without any problems. You need to check whether you need to do pre-annealing of the material after casting it, or you need to do annealing after making the final product. These two are very much important. Same thing with hardening. Whether you need to harden the block of the metal before machining it or after the component is ready, you need to harden it. These things are very important that you need to do an R&D on before you supply to the client, so you know the answers for future if it is going to be a long product. Like if it is going to go in the automotive industry, then you need to know these answers before, so that next time when you get a repeat order or a problem, you already have an answer to it. So cast parts have different grades for forging and for rolled. So don't do just a copy-paste design, or don't just do what the customer has told you. Do these things sometimes and it can really help. Like for example, we supply to ISRO a special material called aluminum beryllium. These ingots are not made in India, it is made in Russia and Kazakhstan and things like that. And it improves the conductivity of aluminum way more than it is. And aluminum is fantastic conductivity. But just by putting some amount of beryllium, it has improved the conductivity and the life of the product. And this product is used in aerospace engines. So where the life is much more important than anything else. Right?
Right. Kairav, tell us what are the different kinds of fabrication methods that are used today?
So the modern technology today is water jet cutting. Okay? Of course, nothing is dead because of that. But water jet machines are fantastic. They are magic. It is water that cuts through metal and gives the shape that you want. It can cut through metal. These machines can cut through glass. It can cut through wood. It can cut through granites. So a lot of these engineering products, these household marbles are cut in the water jet cutting machines. And the best part about it is it does not change the condition of the metal, because the water jet machines are using water. They are not using any kind of heat. Suppose you heat a metal, the properties change a little bit. Okay, so especially in if you're not heating it to a regular, if you're heating it to a regular temperature like just boiling water, then it doesn't matter too much. But if you're using a laser machine, the properties, especially at the edges, become very good. The edges start burning. You will see a black mark on the edges because it's been cut with laser. So you will see those noticeable problems. Now, because of which you have to leave a special space so that you cut that part off and you use the part which is not damaged. So water jet avoids that. It will not have any kind of damage on the sides. So water jet is one of the amazing new technology that is used for cutting and things like that. But of course, you have to do cutting is only one of the first processes that you do before you do bending, welding, other machining, casting, forging, or extrusion, or surface finish, or surface coatings. So you have to do a lot of process goes in different kind of making different products. Whether that process is important or not is usually known to the guy who manufactures it, right? But you can reduce your wastage by using a better machine and reduce your time cycle. Because today, earlier there was a bending machine where could bend only one particular angle. Now there are bending machines which are much faster and can bend many more angles. So that way you are saving space as well as time to pick up the metal and again put it on another machine and again do the next process. One machine can do many processes, and that way you save time, labor, and so much more.
Got it, understood. Kairav, how can MSMEs work better with vendors or consultants to ensure that they're not over or under specifying their metals?
You have to share the actual usage conditions, not just drawings. What people do is mostly they will share a drawing with you, right? Say, hey, I need to make this part. This is the drawing. This is the material I need. This is a usual common practice that happens. Very seldom, a supplier or a manufacturer will ask saying what is the condition you're going to be using it. Very seldom, as we discussed before, same problem. So they don't do this, right? So when you are not telling your consultant or your supplier about it, how is he going to help you? You're not asking for help. Nobody's going to help you. Everybody is busy, right? You're just going to send an email saying, I want this. He's going to ship you that. He's going to quote to you that, or he's going to ship you that. He's not going to ask you that, do you need something cheaper? Do you need something better? Do you need something that lasts longer? What are the certifications do you need? You need to ask for this. Say, hey, I need these certifications. I need to know, is there an alternative to this? Right? It's not only about the price. It's also about the weight, the overall weight. Like if I'm doing exports and my shipping cost is going to be something, then my weight of my end product also will matter. Even India, for example. But if I'm doing a shipping to foreign country where the shipping costs are very high, it will matter. So you need to give more details. Consultants will never necessarily know to ask you these details because they want to also help you close your deal faster. They are there to assist you to close your deal faster. But if you have not shared these problems, they will never be able to come back to you saying that, how you never asked me. If you've not asked, how will you know? A good vendor is not somebody who only saves your money once. He is a guy who saves you a lot of time and energy later by giving you the right advice. So talk to more vendors, have a kind of always ask, is there an alternative in your email or in a request or something? Is there a better product with a new materials flowing from all over the world? Is there a better technology for me to manufacture this? Sometimes it is also that a semi-ready product is available to you at a cheaper price than fully you're still buying the raw material, doing the whole process, and you're spending so many man hours doing that. So you need to know whether this process that I'm doing, is it still worth it, and can I have a cheaper source of supply if I make a ready product, or I buy some stages of my production can be reduced by buying some ready product from someone. That can really help them. But yes, you need to be openly sharing all the pros and cons of your end users so that the consultant or the supplier will do.
And according to you, Kairav, are there any low-cost testing or quality assurance methods that MSMEs can use to validate their metal selection decisions?
Oh yes, of course. Like these days you get a PMI machines. Okay, it's a very common thing in the metal market. Okay, now this PMI machine it's like a gun. It's a gun reader, kind of like a barcode scanner kind of thing. Okay, all they do is they point it to the metal so let's say 5-10 seconds, and they will tell you exactly which metal it is. And that can be done for $50 sometimes, as low as $50. So that is one of the cheapest way to first ensure the base metal. So especially for the regular grades of alloy of steel or copper or steel, copper, aluminium, and all that, it is fantastic to use these PMI machines. They work fabulously well, and but they can't be, you can't check hardness on them. So if you need to check hardness, or you need a government mill TC, or you require a special test report that needs to be supplied to the client who needs a certificate from an NABL lab, that is National Recognized Lab by the Government of India. Then you need to send it to these labs, a small sample, approve it, and get the reports, and then supply it with your product, or get it pre-approved from the client to avoid problems later. That is a little more expensive, I would put it, but sometimes that is the only solution that you have. But PMI works mostly fantastically well. If you are regularly using steel, copper, glass, just do a PMI and make sure you are getting the right product.
Got it. Kairav, my last question for today's session. What would be your top 3 rules of thumb for any MSME looking to make smarter metal choices starting today?
Okay. Always ask the customer, where is he using it? Always ask the customer, what are the problems he's been facing in the past with his metals? Ask the downtime, ask the areas environment where he's using it. Ask him what is the problem that his customer, your customer's customer is facing, and try to solve it at that level. Right? And then you look at the cost of the material, that if you're going to be replacing, what is the cost going to be, what is the grade going to be, what is the condition going to be, is it as per the requirement, or are you just adding a cost for no reason at all? Yeah, so that is more important. So in my since we are in third generation of business, in my father's all quotes, he always writes, quest for quality is passport to prosperity. So this is what we believe in since many years. So I would put it this way, that most manufacturing problems don't start at the shop floor. They start by making the wrong metal choice. And they don't start by the production people. It is started by the conversation that the procurement and the purchase guys are having with their vendors. If we solve this at an early stage, we are going to be in much more better situation. So we as a company, we supply specialized materials, as you know. So things like beryllium, copper, titanium, nickel alloys, new metal, radiation shielding materials. These are used where there is a lot of radiation due to mobile towers. So we need to secure those areas. So we are specialized into that. We also supply high temperature cables for 1000-degree applications. And this is our forte. We have been doing Rework since quite a long time. We are one of the Rework suppliers in India since a very, very long time. We procure from everywhere in the world and we sell to almost everywhere. Yeah. We are a small organization or a growing organization. Our motto is not to sell something cheap. Our motto is to sell something that is direct and right. We want our customer to be happy and we want his customers to be happy too and be safe. Right? So as you said very well, safety cannot be compromised. Yes, you're right, safety cannot be compromised. So we need to keep that in mind before doing anything ahead.
With that, we've come today to the end of today's episode, Kairav. Thank you so much for being with us and for sharing your intelligent insights with our attendees. I am 100% sure that the insights and examples that you shared with our attendees today will benefit them in the long run. Thank you.
Thank you, Amrita. Thank you. Have a lovely day.
You too. For our attendees who are online, if you'd like to view the current episode, if you've missed any part of the current episode which was so insightful, please go on YouTube, type GSW1 MSME and you'll find all our episodes included there. Thank you once again, Kairav. Bye-bye.
If you need to know more about metals, you can follow my channel, which is up there. And I talk about a lot of metals and a lot of alloys which can be used for many applications. And you can come back to me. I'm always a call away.
Thank you. Thanks for that. Thank you so much. Bye-bye.
Have a nice day. Bye.
Bye.